Hello, and today we're going to learn how to simplify complex fractions. There's two ways of doing this. One is to clear complex fractions by multiplying by an LCD, and then the second way is to combine your numerator and denominator into single fractions and then multiply by the reciprocal. We're going to go over both using the same example for both methods. Alright, so here we have the complex fractions. We have a fraction within a fraction. We have 2 over x plus 2 in the numerator and 4 over x plus 2 in the denominator. So first we're going to try to clear this by multiplying by an LCD. So let's first figure out what that LCD is. The LCD is the least common denominator in each individual fraction that you find. So 2 over x plus 2 is the denominator of that. And then 4 over x is the denominator of that. This doesn't have a denominator, so my LCD is x plus 2 times x. So we're going to multiply every term by that, okay? Let's do that. So we have 2 times x plus 2 times x over x plus 2, all divided by 4 times x plus 2 times x over x plus 2 times x plus 2. So every term got multiplied by the LCD. Now notice that in the numerator, x plus 2 over x plus 2 will reduce, so you just get 2x. In the denominator, x over x will reduce, so you'll get, and I'm going to expand this out here, 4x plus 8. Here, because the x over x reduced, here you just get 2 times x plus 2, which I'm going to expand that out as well, 2x squared plus 4x. Hey, we got rid of our complex fraction. So now we're just dealing with reducing a regular rational expression. To do that, we need to put it in factored form, so let's do that. Let's start by grouping all of our like terms and rewriting this in standard form. So we have 2x divided by 2x squared plus 8x plus 8. I immediately notice that every single thing in my entire fraction is divisible by 2, so I'm going to reduce every single term by 2. So we'd have x over x squared plus 4x plus 4. Okay, and let's just make sure that we factor this to make sure there's no extra little factors hanging around. There shouldn't be, but we have x divided by, this is x plus 2 times x plus 2, or x plus 2 squared. And notice that in either of these cases, there's no factors that are common in the top and the bottom. Alright, let's go back up here and make sure that we include those little x restrictions. So in this, x cannot be negative 2, because if it was, this would be an undefined expression. So if x is not equal to negative 2, in this expression, x can't be 0. Otherwise, the denominator being 0 here, this would be undefined. So x can't be negative 2, and x can't be 0. If x is neither of these two values, then this left side of the equation, 2 over x plus 2 divided by 4 over x plus 2, is indeed equal to this expression for all values of x that are not this. Okay, that's using an LCD to clear out your fractions. So notice that as soon as you multiply everything by the LCD, you would immediately get rid of your complex fraction. Alright, now let's take a look at another method, which is to combine your numerators into one fraction and your denominators into another fraction. Notice my numerator already is one fraction, so we can just leave that as 2 over x plus 2. In the denominator, we have a sum which we could combine into one fraction if we created a common denominator. So if we did that, this would be 4 over x plus, we need this to be in terms of x, so it would be 2x over x. Then we'd end up getting, when you combined them, 2 over x plus 2 divided by 2x plus 4 over x. Alrighty. Alright, let's multiply by the reciprocal now. So we have one fraction divided by another, and you've learned a while ago that if you're dividing fractions, it's the same as multiplying by the reciprocal. So really what we have is 2 over x plus 2 times x over 2x plus 4. Okay? So if we multiply across the top and the bottom, multiplying is the nicest possible thing you can do when you have fractions. You have x plus 2 times 2x plus 4. Okay? Multiply these two together. I'm not expanding it out, and you'll see why in a second, because we always want to have our fractions in factored form in order to see if anything reduces. Alright, 2x can't be reduced, x plus 2 can't be reduced, 2x plus 4 can be. We can factor out a 2, so we get 2x divided by, factor out that 2. we have x plus 2, and then this is also an x plus 2, so really we have x plus 2 squared. And notice that the 2, we have a 2 on the top as a factor, a 2 on the bottom as a factor, so the 2's reduce. We have x over x plus 2 squared. Alrighty. So once again, regardless of which method you use, you need to make sure you include those little restrictions on x. So here, my denominator can't be 0, so x cannot equal negative 2. And my denominator here can't be 0, so x cannot equal 0. So those are two values of x that this reduced form will not work if x is either negative 2 or 0. Alright, and those are the two ways that you can reduce a complex fraction.